Let's turn off the light. All you see is black, but that does not change the fact that the Rubik's Cube is still there. Physically, the cube remains the same whether the light is on or off. Obviously, you can't see it because there is no light. But what exactly happened to its color? What color is the Rubik's Cube? Colors are awesome. Without colors, the world would be dull. But what is a color? The colors are red, green, blue, but what are these? Colors are light. Light is part of electromagnetic radiation with a frequency between 400 terahertz to 800 terahertz. Between them for every frequency is every different color. One thing you have to believe is that the light is the same thing that comes from your router, electromagnetic radiation. The only difference is frequency. The visible light that we are able to see is a small part of the large electromagnetic spectrum, and under the part all colors. What makes red color different from green? Well, the same thing that makes light different from the radiation coming from your router. Frequency. Every different frequency makes every color different. But who assigns colors to frequencies? We will explain that soon. For now, let's understand how an object gets its color. When light from a source hits an object, three possible scenarios can happen here. The object may reflect the light, or absorb the light, or transmit the light. Reflection means light hits and reflects in another direction. Or the object could trap the light inside it by absorbing it. Or a transparent object like glass can pass the light through it. However, when reflection or absorption occurs, it isn't necessary that it will absorb the whole light. The object could reflect or absorb a part of the light. For example, if a mixed light of red and green hits an object, the object can absorb the green light and reflect the red. Or a mix of red, green, and blue light hits an object. It could absorb green and blue and reflect red. In this case, the inside of the object is green and blue, and it reflects red. So what color is the object? To answer this, we need to know how we see things. People in ancient times thought our eyes emit light to help us to see, which is known as the emission theory of vision. This theory was even believed by people like Plato and Ptolemy. It was up until the 11th century that an Arab scientist named Ibn al-Haytham explained eyes don't emit light, instead emitted light comes to the eye. So, the color of an object should be the light that comes from or reflects from it. So if an object only reflects red color and absorbs all other colors, it will look red, even though it has every color inside it, except for red. I find this interesting. A red ball under sunlight will absorb all colors of sunlight, but reflect red, which will be the color that we will find as the only light coming into our eye. Which frequencies are absorbed or reflected depends on the object's material. A metal object like silver reflects most of the light because its atoms bounce back the light. A non-metal like wood absorbs most of the light because its atoms trap light into them. This is how they are built. I said every frequency is a different color. But who assigns these colors? You, your brain. When light with different frequencies hits your eye sends another signal to your brain. Then what? Your brain just interprets them as color. How a color will look is a decision of your brain. Does this mean color is just an illusion? Well, this is a universal truth. Let me explain it a little bit to you. Imagine there is a light bulb, a banana, and there is you. The light from the bulb will hit the banana and bound back to your eye. The light is nothing but some energy, some colorless energy. When the energy hits your eye will send a signal to your brain saying an energy hit me with this frequency, and then your brain will decide which color should be assigned to this frequency. Most of the time, the decision is the same for every individual. Your brain and my brain may make different decisions. There is no way we can know. However, if the bulb emits white light, which means all frequencies of visible light are present, the banana will absorb all frequencies of the light and only reflect one frequency that looks like yellow to our brain, which is why the banana looks yellow. But what if the bulb emits all frequencies except for the frequency that the banana reflects? Now, what will the banana look like since the banana not reflecting any light at all? You literally can't see the banana at all. Now, what if we turn off the bulb? There is no light, nor is the banana reflecting light or absorbing any light. The banana is now colorless? Well, it was never colorful. It is just our brain that interprets some pieces of energy as colors. Just an illusion of our brain. You are colorless. I am colorless. The banana is colorless. The Rubik's Cube is colorless. The only colorful is our brain.